Okay, so on to hyperbolas, which are not as horrible as you may think they're going to be. The number one difference here is there's a minus sign in the equation. And what that's going to do is instead of pulling the shape together to form an ellipse, it's going to tear the shape apart, which creates these two opposite parabolas. So, your picture's either going to be looking like this, or it could be vertically aligned, okay? Now, the way you're going to know that is by who leads the equation. Whoever ends up in front of the minus sign, the positive term dictates if it's going to be side to side or up and down. So let's start our completing the square process that we've been talking about and see what ends up happening, okay? So I'm going to go kind of quickly through this. Group the x's together, leave a space. Group the y's together, leave a space, and move my constant to the other side. Now remember from the last video, you want there to be a 1 in front of your squared term. And once there is, you are ready to take half of that and square it. And whatever you do to one side, you do to the other. Now right here, I can't fill this in yet because there is a coefficient on the y squared. So underneath it, I'm just going to or off to the side, I'm going to go ahead and factor out that -2. And yes, you do need to actually factor out the negative as well as the 2. So that's going to make this a -4y. Okay, here's where I'm completing the square. Half of 4 is 2, 2 squared is a 4. Now I've just added 4 times the -2 in the front, so I need a -8 over here. So whatever you do to one side, you do to the other. Remember, this -2 does affect this +4 because of factoring and distributing and all that good stuff. So now we're ready to pull this down to the next step, which means factoring. So this is just going to be x minus 5 squared. I'm going to recopy the -2, that'll be a y minus 2 squared, and then I put all of these numbers together and it looks like I'm getting a 16. Is that correct? 24? Yes, 16. So this is starting to fall into shape, but we need a 1 over here on the right, and it's a 16, so the way we get rid of that is divide by whatever number is there, and then we simplify that. So this is already simplified. We've got x minus 5 squared over 16. When I reduce this, I'm going to get y minus 2 squared over 8 equals 1. Now it looks like the standard form that's shown above. Also, I know that since the x is in front of the minus, this will go side to side. So x means it's a horizontal hyperbola, okay? So how do we do this? Well, I'm going to go through and just graph it slowly for you. I'll be graphing over here and listing out my stuff as I go. I first identify the center, and the center of the shape is, of course, the HK, which in this case is a 5 and a 2. So 1, 2, 3, 4, 5, 1, 2. Beautiful. Now we already talked about the whole side to side thing. We know it's going to go side to side, and as far as where you start that's still called your vertices. And to get your vertices, you need to go left and right the square root of 16, which is 4. So I'm going to go left and right 4, and that is where this is going to start. 1, 2, 3, 4. Awesome. So if you want to just have just a general picture before you find every little part, I mean, you can go ahead and sketch like, oh, it's going to look something like that. We just don't know exactly how steep these curves are yet. And in order to find out exactly how fat or narrow they are, you have to find the asymptotes. And if your teacher mentioned that and you were like, what the heck? The asymptotes are found, for me, you can do it a couple of ways. I actually draw a box. Like for instance, I've already gone left and right 4, because that was the number under 16. Now I need to go up and down the square root of 8. So the number under the y is my up and down. Now the square root of 8 is really close to 3, right? Because the square root of 9 is 3. So it's like almost 3. And yes, I'm going to write that, almost 3. So when I go left and right 4, from these points, I'm actually going to go up and down almost 3 and put a smaller little coordinate right there. So 1, 2, 3. So almost 3. Almost 3, almost 3. That right there that I just drew, I know it's really hard to see. This is sort of I'm going to draw a box around this. This rectangle dictates the asymptotes, which dictate how fat the shape is. So I've made a box out of the whole up and down root 8, left and right root 16, and I'm going to draw diagonals through said box. These diagonals tell me how wide the hyperbola needs to be, and honestly I'm pretty proud of myself because look how well that red traces up to the green. I'm actually not even going to redraw it. I think it looks pretty good. So if your teacher's talking about asymptotes, you're like, oh my gosh, what are they doing with asymptotes? All they're doing is they're finding the slope of these asymptotes, okay, and then they're figuring out like their y-intercept. So you start with, it's almost like transformations. So the asymptotes, you can do like a y equals mx plus b, kind of, but not really. Instead, it's going to be whatever your x was needs to be moved to wherever your x is supposed to be moved. So I'm going to do an x minus 5 because of where my center is, and I'm actually going to put a plus 2 on the outside because that's how high up my center is, and then I'm going to put a slope in the front of this. So the slope, the way you find that, think about slope, y'all, it's the change in y over the change in x. And so for me, I look at the numbers under the y and the x. So the square root of 8 over the square root of 16. So that would be the equation of the asymptote. So if that was throwing you in class and you're like, oh my gosh, what does this even mean? Okay, it doesn't really matter if you understand exactly what it means, because you can always graph it using this box rectangle method that I just showed you. You do need to be able to put it into this form, but notice I just looked at my center, and then I stuck the whatchamacallits, the y over the x in there for the slope. So there you have it, graphing a hyperbola. Let me know if you come across any tricky ones that you want me to work. Thanks.